5% of a batch of batteries are defective. A random sample of 80 batteries is taken with replacement. Find the mean and standard deviation of the number of defective batteries in the sample. Looking at this, I know I've got a binomial probability situation. I know that because you've got the number of trials involved. Firstly, these 80 batteries taken. All trials are independent of each other. I know that because it says a battery is taken with replacement. So once you put the battery back, you ensure that it's going to be exactly the same situation next time. We have a fixed probability of success. It's 5% of a batch of batteries are defective. And also, on any given trial, there's only two possible outcomes: success and failure. Success being a defective battery, failure being a non-defective battery. But there's only two possible things, binomial. So if we define the random variable, let x be the random variable. So it better be the number of defective batteries. Okay, so we defined our random variable. Now we need to say how is it distributed, and I've just said it's a binomial distribution, so x is distributed binomially. You can just write b by all means, but this is a habit that I've had for a long time. And the binomial distribution is defined with n, number of trials. In this case, it's the 80 batteries that we take. And then p, the probability of a battery being defective. So it is going to be 0.05. Right, so what we need to do, we have been asked for the mean and the standard deviation. Right, so mean, we could say that's mu, or ex, the expected value of x, well, it's just np, so that would be 80 times 0.05. So if you think we're finding 5% of 80, well, 10% of 80 is 8, so 5% of 80 must be 4, so that's 4 batteries. So on average, if we say took one of these samples every day for a long time, on average you would expect a mean of 4 defective batteries per sample, unless things changed. So for the standard deviation, well, we know that the variance is np 1 minus p, so variance of x equals np times 1 minus p, so that would be n, 80, times p, 0.05, which we actually know that 80 times 0.05 is 4 anyway from the first bit, times 1 minus p is 0.95. So what you've got really now is 80 times 0.05 is 4, so 4 times with 95% of 4, really. If you think of the number 4, well, 10% is 0.4, so 5% must be 0.2. 100% is 4, so 95% must be 3.8 equals 3.8 MP. So that's the variance. Now the standard deviation, sigma x, well, we know that's the square root of the variance, so it must be the square root of 3.8, which I am going to need a calculator for. So the square root of 3.8 is, to 3 significant figures, 1.95. That's 1.95 batteries. I guess standard deviation will make a lot more sense to you when we study the normal distribution.